to n of x sub I minus x bar, quantity squared divided by n. And when you're using a sample to estimate population variance, you might use n minus 1 or multiply this by the equation n minus 1 over n to make it a little bigger to estimate it in an unbiased estimate of the population, but for our purposes we'll go with the straight definition. Square root of the variance is the standard deviation, and the standard score of x is x sub I minus x bar divided by s of x. We're certainly going to need that today for, well, for the next problem and for what's coming up next. Draw and label the standard normal distribution. So you draw your symmetric bell curve to the best you can do. There's 0 in the middle, and our landmarks, -1, -2, and so on. And the area between 0 and 1 is 0.34, and between 0 and -1 is also 0.34, and between 1 and 2 is 0.135. Between -1 and -2 is 0.135, and from 2 to positive infinity is 0.025, from -2 to negative infinity is 0.025. How many got the variance? No, it looks like everybody. Standard deviation, the z-score, the standard score. You need to know this one absolutely, memorize this. Normal curve, areas under the normal curve. Looks like most people, if not, memorize that. Chant the areas. Any questions about that? I'm assigning to you, listed under here is to memorize the next equation, which is going to be the equation for the correlation coefficient. So we'll write that for you right now. That's r sub xy is equal to the sum from I equals 1 to n of z sub x sub I times z sub y sub I divided by n. So you find the z-score of x and the z-score of y, you multiply them together, you add them up and divide by n, and that's the correlation coefficient. There are more complicated formulas, but I want you to remember this one. You can derive the others from this. The other formulas are there just as a kind of historical note for the days when people didn't have computers. This equation works just fine with computers, but in the old days when you had calculators that had no memory in them, they had other equations that you didn't have to remember anything, so for desktop calculators. But those days are long, long gone. So this is the equation for that I want you to know for correlation coefficient. Find the percentage who have scores above 130. Well, when you do a normal distribution problem, you draw your standard normal curve. So we'll come back to the correlation coefficient here in a bit. And corresponding to 0, you put the mean, that's 100, and then add 1 standard deviation, so that's 115. So we're adding 15 to the 100, add another 15, you get to 130. And so a z-score of 1, these are the z sub x sub i's, and these are the x sub i's. 115 has a z-score of 1, and 130 has a z-score of 2. Subtract 15. Takes us down to 85, that corresponds to a z-score of -1, subtract another 15, takes us to 70, that corresponds to a z-score of -2. Percentage above 130 would be 0.025 or 2.5%, so that's 2.5%. Greater than 115 would be 0.135 plus 0.025, that adds up to 0.16, so 16%. Above 100, that's everything on one side, so that's 0.5. It's symmetric, so 50% on each side, so 50%. And in this normal distribution, the mean is the same as the median is equal to the mode equals the midpoint. So all those measures of central tendency are the same in this normal distribution. So 50% is the mean and also the median at 100. At 85, it's 50% plus 0.34 is 84%. How many got those? All right, any questions about how to do those kind of problems? Yeah, question? You were just saying you got it right. Okay, Any questions about one or two so far? All right, which is more accurate prediction of human behavior? If you're trying to predict who's going to commit a crime, which couple is going to get divorced, how long somebody's going to live, how successful somebody will be in medical school, like, do you have a psychiatrist to ask if the guy is wearing new socks and use a human to make the prediction, or use a statistical formula? That was the one item that came out a little screwy on the exam. Except for that item, the exam looked pretty good. So that item was deleted. How many said it's the clinician that's more accurate? How many said it's the stat formula? Okay, then you should have gotten that item right, see? So the class knew the right answer, but didn't choose the right answer on the exam on this case. For some reason that item was a little funny. I asked about Dawes' example, where the marriage counselors were asked to predict which couples were going to get divorced. He asked these two questions. How many times per week do you have sex, and how many times per week do you fight? And if there was more love than war, then he predicted they would stay together, and if there was more fighting than lovemaking, he predicted they were going to get divorced. And that's a better prediction than just asking the counselors that have worked with them. Counselors know the answer to those questions. They've also listened to these people talk about each other. They've heard their complaints. They've listened for a whole year or more to their people's stories, and yet they're worse at making predictions. Of course, that's an argument for learning statistics, because it means you're better off not listening to an expert who does it intuitively. You're better off doing the calculation. Better off not asking the person that rings up your grocery to use the calculator to do it, rather than look in your basket and say, I think that'll be about $88.15 for your basket of groceries. All right, so that was the one item that was a little peculiar. Otherwise, that's why there's 48 items instead of 49. Okay, what is grading on the curve? Now, always when I ask this question, some people say it's this. What you do is you find out what's the top score, and you grade everybody compared to the top score. And the way to do this is you transform each person's score by setting T is equal to the person's score. So you take person's score on a test, and you divide it by X max, and that tells you what percentage of the highest score it is. And then you multiply that by 100, and if it's greater than or equal to 90, you call that an A, and if it's greater than or equal to 80, you call that a B, and if it's greater than or equal to 70, you call that a C, greater than or equal to 60, you call that a D. Otherwise, it's an F. Hopefully you didn't say that. I know a lot of you did, but I'll check the quizzes and we'll see. How many of you have experienced somebody doing this? Saying that they did that. Most students have had experience with somebody doing that. Well, this is a stupid procedure, and you're going to learn all about it in class today and by doing homework number 16. And one of the things that kind of should seem surprising, students are sort of experts at taking tests and getting grades, right? And some people care about their grades. They would like the grades to be assigned by a reasonable process. And yet, some people will go ahead and use this system, which is not a reasonable process. And, you know, if you know somebody's used this system, or if somebody does it at one of your other classes, tell them to do assignment number 16. I'll give you a link to it that you don't need to go through titanium to get there. Tell them, you know, to read that and do that homework problem so they can understand what's wrong with it. So let's review some of the problems that are wrong with it. It's capricious in the sense that everybody's grade suddenly in a whole class depends on one person's score, and this is a highly variable number. The high score depends on one person being there, right? Some classes, the high score on a test, you have a like Physics 101 course, the high score is 95 and the next score is 37. You have a whole lot of scores between 0 and 37 and this one 95. If you could kill that one person, all the grades would go up. That's why it's dangerous to raise your hand in many classes. You notice I've been telling you, you don't have to worry about raising your hand. I don't use this system, so you don't need to worry about being that person. in this class. If you could kill that one person, all the grades would go up. Or if that person drops this section and switches into another section, all the grades go up in one section and all the grades in the other section go down because that person switched sections. Does that make sense that everybody's grades depend on whether the guy took Physics 101 or Psych 101 at Tuesday, Thursday, at 2:30, or Monday, Wednesday, Friday at 9 in the morning? Or Monday, Wednesday, Friday at 9 instead of Monday, Wednesday, Friday at 11? Person switches from 9 o'clock to 11 o'clock and all the grades in both sections change? That's a silly property. Let's take a look at something else about it. Is it particularly lenient? Well, suppose we have a test that's well designed that gives a nice, we're going to be learning about tests in here a little bit. If you've got a range of scores that can go from 0 to 100, you'd like to have a nice round normal distribution. Maybe you have a normal distribution with a mean of 100. I mean, if it has 100 points, with a mean of 50 and maybe a standard deviation of 10. Well, wait a minute. Who gets an A in this class? Well, you got one score at 100, right? That person gets an A. How many people get a B? Nobody. How many get a C? 2.5% on this normal distribution. So if you have a mean 50 and a standard deviation of 10, you're going to give 2.5% C's, 13.5% D's, and everybody else is going to get F's, 84% F's. So this is not a particularly lenient way to grade. That's 2 strikes against it. Now let's just take a look at the instructor's decision of what kind of test to make. Let's say the instructor has some material and some guy knows 50% of the material. And instructor A gives a true-false test. Let's see how that person is going to do on a true-false test. So this person knows 50% of the material. Let's say there's 100 items on the test. So this person knows 50 of them, right? It doesn't know the other 50. What's the person going to do? It's true-false, right? What do you do if you don't know the answer?
Guess.
You should guess. So how many are they going to get right by guessing?
25.
50-50, right? So they're going to get 25 by guessing. That's a score of 75. What grade is that on that scale? That's a C. So this guy's, yeah, C plus, somebody said. So this person gets a C. Now instructor B, he didn't talk to instructor A, so instructor A is teaching the course at 9 in the morning. Instructor B is teaching the same course at 10 in the morning. Instructor B says, I think I'll give 5 alternative multiple choice tests. And so now if this same student had been in instructor B's class, he's going to get 50 that he knows. And how many is he going to guess now? 5 alternative multiple choice, right? So one chance out of 5, out of 50, how many is he going to get right? Out of 50 doesn't know. 10, 1/5, right? So he's going to get 10 by guessing. I'll write this out so you can get it in your note. So he's going to guess 25 because it's 50-50, it's true-false. This one is 5 alternative forced choice. AFC stands for 5 alternative forced choice test. So out of 5 alternative, he's going to guess 10 by guessing. And so what's his score going to be? 60. So simply by switching from instructor A to instructor B, this same person can go from getting a C or C plus, if you want to call it that, to borderline between D and F. So 60 like barely makes a D or barely fails to get a D. So the grade depends on which instructor you happen to sign up for and what kind of test they decided to use. So this scaling method makes no sense. The numbers used this way to create grades is just a ridiculous thing to do. You shouldn't let anybody do it. I know that's happened to you already, because when I asked students, they said, oh yeah, my high school, all the teachers did this sort of thing, use these kind of scales. It makes absolutely no sense. Have them read the assignment here. You can copy and paste it from homework number 16 and email it to them. Figure out which instructors do it. If you've got instructors that are doing this now, give them the link to it. And I'll give you a link to a URL where you don't need to be in titanium. Everybody clear on this method? This is not grading on the curve either. So this is not what is called grading on curve. I call it grading on the maximum, but some people think it's grading on the curve, and it is not grading on the curve. There is no curve in it at all. This is a linear transformation. Ti equals xi divided by x max times 100 is not a curve. There is no curve in it at all. All right? So that is not grading on the curve. That's called grading on the max. What is grading on the curve? So hopefully you didn't say that was grading on the curve, and let's hope you didn't say it was good. But at least after this lecture, you should understand what's wrong with this system. It is not grading on the curve, and it's not good. I already gave you 3 strikes against it. There's other things I could say, but 3 strikes should be enough against that method. All right. Method number 2 is not lenient either. So, not lenient, it's capricious. Depends on one maximum score. Depends on what section you're in. Depends on what type of test the instructor makes. And then, of course, besides changing the number of alternatives, you can phrase the same question a lot of different ways, making the question harder or easier. So the instructor cannot scale things in a proper way so that this kind of procedure can make sense. All right. What is grading on the curve? Well, you've learned the curve already. This is the curve that they talk about when they talk about grading on the curve, and you've already learned something about it. It's the normal curve, the bell curve, which is used to grade on a curve. So here's an example of grading on the curve. A person might say, what you should do this is going by the curve, grading on the curve, is you take each person's score and you calculate z sub x sub I equals x sub I minus x bar divided by s sub x. And so you're going to do this as part of your homework, is calculate your z score and figure out what grade you'd get based on grading on the curve. And grading on the curve might go this way. If this is greater than or equal to 2, you get an A+. And if it's greater than or equal to 1, you get an A. And if it's greater than or equal to 0, you get a B. And if it's greater than or equal to -1, you get a C. If it's greater than or equal to -2, you get a D, and otherwise it's an F. And that means you're going to give, assuming you have a normal distribution, there will be 2.5% A pluses. There will be 13.5% A's, there will be 34% B's, there will be 34% C's, there will be 13.5% D's, and there will be 2.5% F's. That's an example of grading on the curve. What are the advantages of it? Well, the advantage compared to the procedures that I just gave you is now your grade depends on everybody else in the class. Because we subtract the mean, that depends on every score. You add up all the scores and divide by the number of scores to get the mean. And you divide by the standard deviation, which tells you where you are compared to the rest of the class. The rest of this particular section of a class. So it is not as capricious in that it is more grounded. The instructor, assuming it's a normal distribution, is always going to give 2.5% A pluses and 13.5% A's and 34% B's and 34% C's, so the instructor can know what the distribution of grades is going to be. And the letter grade tells somebody else reading your transcript, oh, this person got an A, that means they were in the top 16% of the class. The top 13.5 or 2.5% compared to the other students who took the same section. So those are arguments that can be said for it. What are some disadvantages of this method? Everybody understand those advantages first. What are some disadvantages? Well, it says that if a whole class were to do really well, the instructor would still give 2.5% A's, 13%, 2.5% A pluses, 13.5%. Even if the whole class did really well, the whole distribution would shift to the right and all the z-scores would adjust to that. And so the instructor would give exactly the same distribution of grades. Or if a whole class were to really screw up and all say to each other, let's all not study, let's all screw up and not learn anything, let's interfere with the ability of the instructor to teach by spilling things and walking back and forth in front of class right before a test. Somebody might do stuff like that in order to prevent material from being presented, because you're all going to get the same grades no matter what, because you're all just compared to each other. Furthermore, what should you do if somebody else says, what did he cover? I was sick and I couldn't go to class. What should you do? Well, it's in your interest not to help them, because you're in competition with each other. So the better the rest of the class does, the worse off you are, because your grade goes down. So if all the people raise their hand, I got it right, you're going, oh, gee, thanks, guys, you're studying. So what you should do is say, I'm not going to study, and then study. Because then everybody else will do poorly, but then you'll do well, and you'll beat them, and you'll get a better grade than they will, because you're in competition with each other. All right, so those are disadvantages of grading on the curve. So those would be arguments, and you could make value judgments about these properties, and I've given you some value judgments on the other one. I think there are some things that are good compared with the other method, namely it depends on all the other students. That's a good compared to the other, but these are disadvantages that I've just cited. Now there's a third procedure that you can do, and that's the one that I use. It has some of the advantages of this method, but avoids the disadvantage, and that's what's known as the historical curve. So if you've been teaching for a while, and I have been, and you know something about psychometrics, and I do, so if you know something about psychometrics, you can design an exam so that you know what the mean and the standard deviation are going to be of the exam based on the past, on how the items have behaved in the past. You can do test item analysis, and we have a course in the upper division that students can take on testing. Unfortunately, it's not required of people that are planning to be teachers. It used to be required of all psych majors, but for some reason they dropped it as a requirement, so it's now an optional course. But if you're planning to be a teacher, I recommend you take it, because you're going to be given tests. And a lot of people receive tests, not only as students, but as people who engage with the healthcare profession. They get medical tests. People that are given other kinds of tests and measures. When you apply for a job, you take various tests. And understanding how tests work, really important to, to psychologists, and to people who are going to be teachers, but also important to people who are going to be consumers of tests, people who are going to use medical tests, pregnancy tests, other kinds of tests that are supposed to predict something. So there's the historical curve. So you can predict from the past what the mean, based on the selection of the items, and standard deviation is going to be. Then calculate the z-scores based on the previous mean and standard deviation based on the history of the items, and then give grades based on that. So that's what I do. So that means you're not in competition with each other in this class. You can help somebody else, and it cannot hurt your grade. It could hurt people in the future. So if this whole class does really well, and you did, so thanks for the birthday present. The class here, we had 50 people, so on grading on the curve, 2.5% of 50 would be one person, right? 2% of 100 would be 2 people out of 100. That's 1 out of 50 is 2%. 2.5 would be 1 or 2 people. We had 8 A pluses. One of those doesn't count because Kyle went and said, halfway through the class, he says, maybe I should take the test too. And spent about 10 minutes on it and got an A+. So that should give you confidence in the test and also in Kyle here. He said, maybe I'll be embarrassed. I said, go ahead, take that. So he doesn't have to be embarrassed. But he was not the high score, so somebody can be proud of that. So he probably didn't do all. Did you do all the reading and homework? Probably he didn't.
No.
He didn't get the book. So All right, so maybe didn't view all those videos. Well, I'll make sure he does next time. All right, so you're not in competition with each other, and there were 15 A's, and 10 plus 15 plus 8 got B or above, so it's like the class did the best ever, so give yourselves a hand. I don't know. I'll post results, but that's not everybody. As you can see, there's a distribution of scores. Now, what does this number represent? We're going to be talking about correlation. Let me go through. So I've talked about